now we'll get into water efficiency. There are 10 points across the board here, so they're all equal. Okay. And we have one extra processed water for schools. So let's go over our terms, which, just to refresh our memory, what they are. Potable water is water that's being treated to a high enough quality that we should be able to drink it. And again, the intent of every single credit in this category is to reduce the amount of potable water we use in our buildings, because if we're treating it to a high enough quality, it's pretty precious, and there's a lot of energy that's gone into treating that water. Let's just use it for consumption and bathing and stuff we actually need that high quality water for. Okay. Black water is water that's wastewater. So that's, in most jurisdictions, water that's come in contact with waste in our toilets or urinals, and water in our dishwashers and kitchen sinks. Because if it touched organic materials, we consider it to be black water. It's different from jurisdiction to jurisdiction. My favorite example is Ohio. So in Ohio, you are allowed to use black water to irrigate your plants. But in most jurisdictions, you're not. Gray water is water we can reuse. So that is either stormwater or water from our bathroom sinks, other sinks, shower water that we can collect and maybe put in our toilets or use it for irrigation later. Processed water is water that's in our building systems. So our cooling towers and chillers, they use processed water, and we don't necessarily need to use potable water. GPF stands for gallons per flush. Flush the toilets, how many gallons go down the drain. Gallons per minute is a flow rate. Turn on the faucet, turn on the shower, how many liters or gallons come out per minute. FTE, as a reminder, is how we measure occupancy in LEED. 1 FTE is equal to 1 40-hour work week, 8 hours a day, 5 days a week. Or for example, 16 people here today, 5 hours each. Right, that's 80 hours, 80 people hours divided by 40. We get 2 full-time equivalents in this room. EPA Act 92 or 2003 is how we define what a conventional building would use and what we compare our design usage rates to. Where do we use that water? As a reminder, 70% of that potable water we use goes to irrigation, 22% industry, and 8% in domestic use. Lots of water. But first we have a prerequisite. That prerequisite is 20% less water, less potable water used in our building as compared to a conventional EPA Act building. Then for credits, if we beat it by 30%, 35%, 40%, you get an additional point. So 30% is 2 points, up to 40%, 4 points, and an exemplary performance point if it's 45% or higher. So now we do need to know these percentages, whereas in the Green Associate we did not. Okay? This baseline and design case calculation includes toilets, urinals, bathroom faucets, showers, kitchen sinks, and pre-rinse spray valves if you have it. However, it does not include the following. So this credit does not take into account dishwashers, commercial ice makers, clothing washers, or commercial steam coolers, because they use so much water to really skew the results. So if you really have a dual flush toilet, it's going to improve your water usage a lot. But if you're including those 4 items that use so much water, that improvement will be minimized, and it's going to skew the results a lot if you include them. Here are our baseline water fixture uses. So toilets, 1.6 gallons per flush. Urinals, 1 gallon per flush. Lavatory faucets, 2.2 gallons per minute coming out of it. All right, and if you have pre-rinse, anything less than 1.6 gallons per minute, 30% for the point. And then residential, the only thing different here in between a residential and commercial building are shower heads. All right. So we might as well quickly run through that calculation because some of us haven't seen it in a while, just showing our baseline. So if you haven't taken the course in quite some time, this is how we calculate our baseline. So here's our fixtures, men, women. If we have 100 FTEs or 200 FTEs, we split it up and say 100 each. This is in our commercial office tower for an example. So in a commercial office tower, what do we have? We have toilets, we have sinks or faucets, and we have urinals, toilets. Okay, so men go to the toilet 1 times 1.6 gallons per flush as per the EPA Act equals 1.6. We use the sink 3 times a day, 3 times 2.2 gallons per minute. Wash our hands for half of a minute equals 3.3 gallons per day. Urinals, men go to the urinal 2 times, 1 equals 2 equals 6.9 times by 100 FTEs equals 690 gallons per day. Whereas women use the toilet 3 times, 1.6 equals 4.8. Faucet usage is the same thing. Wash your hands 3 times. No urinal. Add that up. It's 8.1 times 8 times 100 equals 810. This is our baseline. Sum those two numbers up, we get 1,500 gallons per day based on EPA Act conventional water usage rate. So for the prerequisite, we need to use 1,200 or less. And then when we go back into do our calculation for our design case, all you do is replace your fixtures. So our low flow toilets only use 1.0, redo the calculation. Our low flow faucets only use 1.2. Our waterless urinals use 0. You do the exact same calculation and you divide the new number with that and you see your difference and how much you are better. The lead online and lead letter template really makes this easy. It's all built in based on your full-time equivalents, and then based on your design fixtures, you just put in your design fixture flush and flow rates, and it does the calculation for you and sees how much better you are. That's it. And also, if you're using all non-potable water for toilets, well, right there, that's 0. Okay. Very simple calculation. Here are some different strategies. So get your baseline water usage rate. That was the 1,500. Okay. Based on your estimated FTEs. And then these are the different items that you can use to lower your potable water usage. Just some examples. There's countless others, whatever you want to design into it. So flow restrictors, automatic faucets that turn off and on when no one's using them, which somehow we haven't really figured out to master because they never work when I put my hand under. I don't know how they've been. How long have we had them? Probably like 50 years. We just can't figure that out. Low flow fixtures, non-potable water fixtures, collecting rainwater, and it's done commercial. And so this is what it looks like on the lead letter template here. So they calculate your baseline. All right, so they tell you these are the EPA Act standards. You put in your full-time equivalents, and then it gives you your baseline water usage. Then you go into your other baseline fixtures if you have them, and finally into the design case. And this is what we are using in our actual building. And it calculates what your design case is, and then just divides the two together, and we get the total water savings based on the difference. So it really does it all for you. You just have to put in how many people are estimated to be using the building and what your design case fixture flow and flush rates would be. And you just submit some kind of narrative showing all the different specifications in your building and what their flush and flow rates are. So that is prerequisite 1. Again, that's 20%. And credit number 3 is the 30%, 35%, 40%. Now we go into just looking at wastewater. If we remember, when we flush our toilet, it's heavier water, so it takes a lot of energy to pump that water all the way out to where it needs to go, then treat it with lovely chemicals and more energy consuming processes, and then pump it all the way back when it's clean and we can use it in our own building. Okay? So there's two ways to do it. Either you reduce the amount of potable water we're using in our wastewater areas, so for example our toilets, and if you reduce it by 50% by using water conserving fixtures like dual flush toilets, no waterless urinals, non-potable water, captured rainwater, recycled gray water, municipally reclaimed and treated water. If you use all of that stuff, which is considered gray water, well, that's a way of offsetting 50% of your potable water that you normally use. Or alternatively, treat it on site. So either have your own wastewater treatment plant on site, or have a lagoon or a septic tank and keep that water on site. That way it does not leave into the municipal wastewater system and have all that energy used for it. And there's an exemplary performance point if this number 50% and 50% here is 100%. Okay? So here are just some things that you have to document. Break it down to how many people are in the building, when is the building being used, to calculate that baseline based on the 1.6 gallon flush rate, GPF flush rate of a toilet, 1.0 flush rate of a urinal, and the exact same thing we did over here, but we're only looking at toilets and urinals. And same thing with on-site wastewater treatment. Just describe it, show how it's designed. Okay, so that was credit number 1. Credit number 2 is innovative wastewater. Credit number 2 is innovative wastewater technology. These are some more examples. So composting toilets and just on-site water treatment. I use this as an example in the Green Associate course. This was a living building challenge building that was a completely natural on-site wastewater treatment facility. And so these are exotic plants that take out the contaminants that our normal conventional wastewater treatment plants would do as well. And that's about it. Any way you can reduce your wastewater is up to you how you do it, as long as you reduce it by 50%. That's credit 2. WEC 3 was optimizing your water usage, and that was a 30%, 35%, 40%. Now we have for water efficient landscaping. So we remember 70% of our potable water goes towards irrigation. That's a lot. And what is our baseline? Our baseline is determined based on our zone, so what location is our building in, and it's based on a midsummer's day, what a conventional irrigation system would use on a midsummer's day. And we need to beat that baseline by 50% for 2 points here. All right? And so remember, the easiest ways to do this are just to specify native and adaptive vegetation. Because if they were there before and they're native to the land, indigenous species, well, they're not going to need more water after we build a building. And they could probably survive on their own. Whereas if you used exotic plants and fancy plants, well, you're probably going to need to water them. They might have high evapotranspiration rates, so they can't hold the water and use it for a long time. It evaporates out into the sky through the plant's leaves. Or you can use efficient irrigation systems like drip irrigation instead of sprinkling the water above it and having some of that water blow off, run off, or evaporate before it gets a chance to go down into the root. Drip irrigation delivers it right to the root, and you can save like 80% of your water compared to a conventional overhead sprinkler. Of course, it's more expensive. Okay. Or using absolutely no potable water. So the first one was using 50% less potable water, through an efficient system, specifying your plant smart, or just using non-potable captured rainwater. This one is using absolutely no potable water, or also known as xeriscaping. Right? Xeriscaping, a big word. Xeriscaping. Xeriscaping. Thank you. So first you have to meet the requirements before us, obviously, because that was only 50%, and now we got to go a little further and either use gray water, and these are 4 examples of gray water, or install landscaping that you don't need any irrigation for. So again, any way that you don't need to irrigate at all. And here are some strategies to do that. Know where your water needs to be used to water your plants and grade your site so the water flows there. Analyze what plant species you're going to use and what soil you're going to use. Use native, adaptive, indigenous species which are used to the land and don't need any extra irrigation to survive. Efficient irrigation, non-potable water irrigation. Mulch the area so it holds that water. Stuff like that. And this is the calculation, which you won't need to know, but I thought I should show you what the different equations we use here and what they all stand for. So you calculate the baseline case based on that midsummer's day. Then you calculate your design case based on what you actually use. And these are, you can, if you're interested in it, you can read into it further in the reference guide, but these are the main requirements, and then all you do is 1 minus your design over your baseline to see the percentage you are better. So just like every other baseline that we use, 1 minus design over baseline times 100 is how much better we are than the baseline. But don't need to read into this too much unless you're actually interested in it. So we've gone through 3 credits: landscaping, innovative wastewater technology, and water efficiency. This one is just for schools. Process water. 1 point if you reduce your process water by 20%. 2 points if you reduce it by 40%. The second point is an innovation and design exemplary performance. So these are the equipment that use process water in a school, and this is the baseline usage rate that we compare it to and want to beat by 20 or 40%. So from clothes washers to dishwashers, ice machines, food steamers, and pre-rinse spray valves. You should think of this in a college residency or college dorm. It would have all of these items in it, right? So we want to reduce that. Okay. Also, this one, no refrigeration equipment using once-through cooling with potable water. That's actually being outlawed in places like California, and by doing that, by only using it once, you are kind of contaminating that water, and whatever was living in it before can't necessarily live in it after it's used. So either we want to reuse water more than once, or have gray water as processed water, or use less of it.